So hello guys, welcome back. Today we will have again some very good questions from Alan All India Test Series, different papers. So here's the first question for today, and I would request you guys, as I always say, to pause the video for a few seconds and try out the question and then come back to see the solution if you can't do it on your own. So I will wait for a few seconds. Okay, so I'm starting off. So basically we have in this question a quadratic equation given as, I will write this quadratic down. This is 8x squared minus 14x plus 3 equals to 0, and its roots are given to be alpha and beta. So before proceeding, let's solve. I guess this is like a solvable quadratic equation. Let's solve this. So basically this is pretty easy to solve. We can split the middle term as minus 12x minus 2x plus 3 equal to 0. So I guess this is your 4x times 2x minus 3 minus 1 times 2x minus 3 equal to 0. So 4x minus 1 into 2x minus 3 equal to 0. So our solutions for this equation are x equal to 1 by 4 and 3 by 2. Now these are given to be alpha and beta, and alpha is less than beta. So basically alpha is 1 by 4, beta is 3 by 2. Now let's look on the question. So basically, which of the following equations has this and this expression? Basically quadratic and complex numbers punched into a question as roots. So let's find out these expressions first. This is your 2 alpha plus root under beta by 2I whole power 50. So if we put the values, this is your half plus root under 3 by 4 is root 3 by 2I power 50. So this is your root 3 plus, I guess, 1I. Okay, just a minute, I guess. Okay, I wrote reverse. I'm sorry. This is okay. I will write it as it is written. 1 plus I root 3 by 2 power 50. So if you look carefully, this is nothing but your minus omega square, because minus is missing, which is cube root of unity. So one of the cube roots of unity, and minus omega square power 50. So basically minus 1 power 50 will obviously become 1, and omega power 2, omega square power 50 is omega power 100, and 100 is divisible by 4, and you guys know that any omega power 4n is always equal to plus 1. So this thing comes out to be, I guess, omega itself. Like if we write this as omega power 100, yeah, it's coming out to be omega. So this was the first part, and now I will change the page once. And here we have a 2 alpha minus of root under beta by 2I whole power 50, which is once again half minus root 3I by 2, and we can write this as minus of, I guess, 1 minus I root 3 by 2. Or okay, I don't need the minus actually. I thought like before we'll need the minus. We don't need minus here. It's given already 50. So this is another cube root of unity. This is actually directly minus omega. So now what we will have is minus omega power 50, which is nothing but your omega square, right? Pretty simple stuff. And now we will I guess we had to say that for what equations are omega and omega square roots. So now let's take a final look at the options. So I guess x square plus x plus 1 is not a correct option, and if we, okay, x square, okay, sorry, x square plus x plus 1 is a correct option. Yeah, a is a correct option, and b is, I guess, not correct, and c can be correct. X cube minus 1 equal to 0, and I guess d is also not correct. So basically our correct options will be a and c, I guess. So this was a pretty simple question. Okay guys, and I did a small mistake. This is not omega, this is 1. Yeah, This thing is actually 1 and this thing is omega square. So 1 and omega square. Basically because omega power 100, right? And 100 is I guess divisible by 4. So omega power 4 into 25, which is omega power 4, and so it should be plus 1. And that's why I guess our correct options will be A and C. This was a pretty simple question, like simple question out of all the difficult questions we have in such papers. So now I will, I guess, proceed to the next question for today. So here's our next question. I will pause for a few seconds for you to try out and pause the video. Okay, so in this question we have ln x given as less than equal to some lambda x cube, and we have to find out the possible values of lambda. So basically if we write lambda, it is greater than equal to ln x by x cube. So let's take this thing to be some f of x, right? So if we find out f dash x, basically we are trying to find out the maximum value of this expression because greater than equal to is there, and we have to also ascertain the possible values of lambda, so we are aiming towards it. So f dash x is basically our x square minus, basically not x square, x cube, and ln x will be differentiated, so x cube by x, that is x square, and this is your minus 3x square ln x whole divided by x cube whole square x power 6. This came out to be 1 minus 3 ln x by x power 4. So basically if we put this equal to 0, our x will come out to be, I guess, as e power 1 by 3. Ln x is 1 by 3, so x is e power 1 by 3. So only critical point we have. So f of x will be maximum at x equal to e power 1 by 3, and its value, I guess, will be f of e power 1 by 3. So if we put e power 1 by 3 in ln x by x cube, it is, I guess, coming out to be e power 1 by 3, right? So 1 by 3 and e power 1 by 3 whole cube, so 1 by 3e. So lambda has to be greater than equal to 1 by 3e. And if we try to find the value, this is 2.3 something, so basically 6.9 roughly, or you can say 1 by 7. So we have to find the possible values of lambda. So lambda has to be greater than equal to 1 by 7 so that we can ascertain. So if we find 1 by 7, I guess it is 1 by 7, let me calculate once. 1 by 7, it is 0.14 something. So I guess in that regard our correct options will be A, C and D, because I guess these are the correct options. A is 0.2, B will not be there, 0.1, less than this. C is 1 and 1 by E squared. 2.3 squared is, if we try to ascertain the value roughly, this is 6, 9, 3 to the 6, 2 to the 4. So calculating 9, 5 and 2 and 5.29. So 1 by 5 also if we take is roughly 0.2 or something like anything. It can be 0.1 something also, but definitely greater than this. I hope you can understand. So A, C, D will be our correct options as per this final condition. So this was also a pretty simple question. And now I will proceed on to the next question for today. So here's our next very good comprehension type question on system of linear equations and some planes also mixed up. So basically this question will go a bit long, so if you guys want, you can pause the video and try out yourself, and then you can come and look. And if you guys want to know the solution also before trying, I will give you the solution. For part 1 the solution will come out to be 7, and for part number 2 the solution will come out to be 24. So these are the two solutions. So now if you want, you can pause the video and try out once. I will wait for a few seconds. Okay, so now I am starting off. So basically let's read it once. So we have ABC, three real numbers, such that the system of linear equations given as this big thing is consistent. So that's the first thing. So you know the condition for consistency is basically capital D equivalent to D1 equal to D2 equal to D3. All of these have to be equal to 0 for a system of equations to be consistent. This is something which we all know. So if we first, let's try to write D. So it will become 10, 13, 16, 11, 14, 17, and 12, 15, 18. I don't know actually if there is any particular way to read determinants. This is how I did in my preparation phase. So as you can see, these are consecutive numbers: 10, 11, 12, 13, 14, 15, 16, 17, 18. So you can, like, what you can do is you can do a C1 as C1 minus C2, and then you will have 1, 1, 1, and then you can do one R1 as R1 minus R2, two rows, any two rows, and finally you will actually get the answer to be 0. This is a very standard sum that you will note in your famous books, or like good books also, that if consecutive numbers are present, the determinant actually turns out to be 0. So I'm not solving this further apart. This is pretty simple stuff. Let's now go for D1. D1 will be A, B, C minus 3, 11, 14, 17, 12, 15, 18. This is your D1. So I will change the page, otherwise I will have lack of space. So let's do one thing. I will do one operation here. What I will basically do is I will do C3 as C3 minus C2. So this thing will become mod of A, B, C minus 3, 11, 14, 17, and 1, 1, 1. Now you can, like, subtract. Like, if you want me to write this out, we can maybe write this something like R2 as R2 minus R1, and R3 as R3 minus R2, something like that. So A, this will be B minus A, this becomes C minus B minus 3, this becomes 11, this becomes 3, 3, I guess 1 minus 1, so 0, 1, this, and these two will be 0 and 0. Let me check once. Yeah, this is the final one. This is A, okay. So now I guess we can pretty easily manipulate this. Open the determinant up. 0, 0, we will not take the terms, only we will take the terms for 1. So 1 into this thing. So 3 times B minus A minus 3 times C minus B minus 3. So 3B minus 3A minus 3C plus 3B, and plus 3 3s are 9. So this is your, I guess, if we take the 3 common out, because 3 is present in all, this will become 2B minus A minus C plus 3. This is your D1. Now let's find out D2 and D3 also. So if you want to find out D2, let's write down D2 first. So this is basically 10, 13, 16. We will have A, B, C minus 3 in the middle column this time, and 12, 15, 18. So what we'll do is, let's do a quick manipulation. What I will do is, just a minute. Okay, let's do R3 as R3 minus R2, and R2 as R2 minus R1. So we will have 10, 3, 3. A, this is B minus A, and this is a C minus A minus, okay, B minus 3, sorry. C minus B minus 3, and 12, 3, 3. And now again, what we can do is, we can write this as 10, 3, 0, A, B minus A, C minus B minus 3, 12, 3, 0. Basically what I did was, I will tell you. Okay guys, there was a small mistake here. This was C minus 2B minus A minus 3. because we basically did R3 as R3 minus R2. So this is C minus B minus A, and this is plus A minus 3. So yeah, and now if you guys calculate this, I'm leaving the calculation part to you guys. This will become minus of C minus 2B plus A minus 3, and here we will have minus 6, I guess. I calculated this out. So this is 6 times C plus A minus 2B minus 3, because this minus and this minus are getting turning into plus. So this is your D2. And now we can find out D3 as well. So let's find out D3. So if we find out D3, this is basically your 10, 13, 16, 11, 14, 17, A, B, C minus 3, I guess. Yeah. So this thing we can do a little bit of manipulation. What I do is I want to make this row 1. So let's do C2 as C2 minus C1. So this is 10, 13, 16. This is 1, 1, 1. And here we will have A, B and C minus 3. And now we can again, like, what we can do is we can write from here, like if you want to change, say I want to change these two to 0, right? So I can do R3 as, or yeah, R3 as R3 minus R2, and after that R2 as R2 minus R1. So we will have 10, 3, 3, 1, 0, 0, A, B minus A and C minus B minus 3. Guys, please note, don't like think like that I'm doing R3 as R3 minus R2. So after I found out B minus A here, after that B minus A and this is getting subtracted. No, this and this are purely independent of each other. Okay, row operations or column operations, if you do, you can, I guess, do a maximum of 2 at a time in a 3 cross 3 determinant, provided that any one of the rows or any one of the columns are kept constant. But in that case, don't like think that they are dependent on each other. They are completely independent. Okay, this is pretty confusing. Like I also used to get confused. So now this is 0 and 0. So basically if we take 1, this is the part we have to evaluate. So 3 into C minus B minus 3 minus 3 into B minus A, and now we can take a 3 common out. So we will have 3 times 2B plus 3 minus A minus C, I guess. This is what we will have. And there's a minus also here. Doesn't matter. This will not matter when we get the result. So yeah, this is our D3. So basically what we need to have is D equals to D1 equals to D2 equals to D3 equal to 0. So let's say if we take this only, what we need to have is 2B plus 3 minus A minus C equal to 0. Or we need to have A plus 2B minus C, sorry, A minus 2B plus C to be equal to minus 3. So this is it. And I guess we are in a good position to now move on to the question, because almost A, B, C and everything, all the parameters we have ready with us. So let's look at the question once. So basically in the first part of the question, we have a matrix, or rather a determinant. Okay, a matrix, and we have to find the determinant. This is A, B, C, 2, 1, 0 and 1, 0 minus 1. So let's find out, calculate this. So if we try to calculate this, this is A, 1 minus 1 is minus A, minus 2 times minus B and 0, so plus 2B, and 1 into B is 0 minus C. So basically this is minus A plus 2B minus C. And once if we look at our result, it was 2B plus 3A equal to A plus C. So minus A plus 2B minus C will be minus 3. So basically this was mod x, our mod x has become minus 3. So we were to find mod x plus 10, which comes out to be 7. This was easy. And now we also have a second part where we have a D plane, that is containing, okay, P plane containing all the points ABC for which this system of linear equations is consistent. So basically the plane equation will be, if we in place of ABC we substitute x, y, z, so minus x plus 2y minus z plus 3 equal to 0. Or rather we can all, okay, this is, you can also change the signs if you want. This is x minus 2y plus z minus 3 equal to 0. So I guess we have to find out the distance of the point minus 900 from this plane and square it up. So let's do that. So minus 9, 0 and 0, which basically becomes minus 9, and this is minus 3 mod whole divided by root under 1 square plus 2 square is 4, 5 plus 1 square again 6. So this is 12 by root 6. And if we square up 12 by root 6, this will be 144 by 6, which is 24. So our final answer is 24. I guess that was asked in our question. I will check once. Yeah, we were asked the value of D. So D, the answer here will be 24. So this was it for this comprehension type question. This was a good question on system of linear equations, because system of linear equations, I don't remember the exact year, but system of linear equations was directly asked as a comprehension type, or either comprehension or it was a matrix match question in JEE Advanced. You can look in the PYQs. So yeah, now we will move on to the next question. So here's our next question for today, and this is a very good question. I would recommend you guys to try this out. This is a very good question. I will wait for a few seconds. Okay, so I'm starting off. So basically here in our question we have a polynomial function, and also we have some information given about f of x. First is f of x is a 1 function, and we have some values, and on the basis of that we have to calculate questions 3 and 4. So let's do that. First I will write out this polynomial equation, which is f of x into f of y plus 2 is equal to f of x plus f of y plus f of xy. So because we have f of 0 and f dash 1, right? We have f dash 1 with us. So let's try to find out f of 1. So what I will do is I will substitute x equal to y equal to 1. Let's try it out and see what happens. So this becomes f square 1 plus 2 equivalent to f of 1 plus f of 1 is 2 f of 1 plus f of 1. So basically it's coming out to be a quadratic. So f square 1 minus 3 times f of 1 plus 2 is equal to 0. So this is pretty easy to solve. Directly f square, I'm sorry, f not f squared 1, f of 1 will come out to be 1 and 2. But one thing which is alarming here is that f of x is a 1 function, right? It's given f of x is a 1 function, and on top of that f of 0 is already given to be 1. So 0 is already mapping to a value 1. That means f of 1 cannot be 1, it has to be 2. So f of 1 is 2, as well as f dash 1 is also 2. That's what we have. And now we have found out that f of 1 and f dash 1 both are 2. So let's, I guess, proceed to finding out f of x finally. Because if you observe question 4, we need to draw graphs. So we'll need f of x. So I will change the page once. So if we try to find out f of x, I will do a small trick. I will substitute y as 1 by x. It's possible here, like, where it will give a good result. This will be f of x into f of 1 by x plus 2 equivalent to f of x plus f of 1 by x, and this is plus f of 1. Now f of 1 is 2 and this is also 2, so they get cancelled. So basically our f of x into f of 1 by x becomes equal to f of x plus f of 1 by x. Now, like if we want to ascertain an approximate form of what this can be, I guess f of x will be something of the form 1 plus minus some x power say n, I guess, because 1 plus minus x power n, and if we put 1 by x, this will become x power n plus minus 1 by x power n. So yeah, it's coming, I guess, because f of x plus 1 by f of x, right? So 1 plus minus x power n plus x power n plus minus 1 by x power n. Yeah, it's coming. So this is, I guess, an approximate form of the f of x function. And now we have two conditions, like f of 1 is 2, which is, I guess, pretty obvious. Okay, f of 1 is 2 will give us that it will not be minus, it will be only plus. This will give us that f of x will be some 1 plus x power n, right? Otherwise the value can't be 2, it will become 0. And finally, if we differentiate f dash x, it will come out to be n x power n minus 1. And we also have f dash 1 as 2. So basically, if we put x equal to 1, we will get n as 2. So our final f of x has come out to be 1 plus x square. And now the questions can be solved easily. So I guess in the first part we were asked f of 5. So let's directly find out. It will be 1 plus 5 square, which is 26. This is the answer for the first part, f of 5. And I will take a look at the second part once. So in the second part, we have a function h of x, which is minimum of 2 by f of x, meaning 2 by 1 plus x square, and mod of 1 minus mod of x, where x, so basically we have to solve this only for x greater than equal to 0, the positive parts. So basically we have to draw out the graphs of all these three functions together and then find out the minimum part, right? I know, I guys, like, this is something that we have encountered for the first time. So I will try to explain it in the finest way possible, and I hope you guys also know how to do this. So let's proceed to drawing the graph for this. So first I will write out what we had. This is h of x equal to minimum of 2 by f of x, which is 2 by 1 plus x square, and x square, and mod of 1 minus mod x. So I guess we have encountered this thing previously in some question, I don't remember, but yeah, I guess we have done this. Anyways, I will do it again. So drawing these two is very easy, but this is a bit complicated, so let's draw it first. So in a small graph, if we draw mod x, this is something like this, y equal to mod x. Then if we try to draw out 1 minus mod x, right? So minus mod x is the same thing, and basically 1 minus mod x is, I guess, 1 shifted downwards. Mod x will actually, 1 minus mod x will be actually inverted like this. So yeah. Okay, just a minute. I guess I did something wrong. Okay guys, there was a small blunder. Minus mod x is actually invert of this, like it will come like this, and we are adding plus 1 to that. So basically it will be this thing, I'm sorry. This is y equal to 1 minus mod x, and now we have put a whole mod on that, so the parts which are below the x-axis will come above. So it's like this, and this is our final y equals to mod of 1 minus mod x. This was pretty simple, although I showed it externally. And now if we try to ascertain the graph for this minimum thing, I will do it. This is, say, our y-axis. This is our x-axis. And now y equal to x square will be something like this. And if we try to draw 2 by 1 plus x square, okay, when x is 0, that is, it is on the y-axis, it is coming to 2, y equals to 2. So basically, if this is 1 and this is 2, the graph of 2 by 1 plus x square at x tends to infinity, this will also, like, I guess x tends to infinity, this will go towards y tends to 0. So something of this sort. It will touch like this and again continue. something of this approximately. And we have the graph ready. Okay, and if you guys observe this intersection point, I will find it out just for your reference. This is 2 by 1 plus x square equal to x square, right? So 2 equal to x square plus x power 4, and x power 4 plus x square minus 2 equal to 0. So x power 4 plus 2x square minus x square minus 2 is 0. So this is x square, I guess, minus 1 times x square plus 2. So this is nothing, like x square can't be minus 2, so x is intersecting at plus minus 1. Yeah. So what I wanted to check is that if these points are actually like this and this are lying underneath each other or not. So yeah, it's doing. So minus 1 and 1. So basically, and our final 1 minus mod x whole mod will come like this. And this will rise like this to 1. Again go like this. And this is somewhat the graph. And now if we want to draw minimum of this, so what I will do is I will try to change the color of the ink. Let's take a red. And yeah, red is okay, I guess. So we have to draw minimum of this curve. So I will color it with red. So basically it's the part of the curve. Minimum means the part of the curve that is least downwards, right? So this, it comes to this, and then again from here to here. Then again this part will be traced. Again this part. Again this part. And finally it will go like this. Yeah, something of this sort. So these red mark points are actually points of non-differentiability because they have sharp corners. I will write also h of x is in red colors. Okay, so let's return to white. And now I guess this is it. And basically, although I drew it for both x, like x negative and x positive, but we have to only find the number of points of non-differentiability at x greater than equal to 0. So our answer will be 3. Overall it's 6, but for x greater than equal to 0, we will not require this part. So our answer will be only 3 for the second part. So this was also a very good question, I guess. And guys, I guess this will be the final question for today. I hope you guys enjoyed the video because today we discussed some really good questions. And I would bring out such questions from test series also in further videos. And if you guys have any problems or doubts, you can always drop in the comment section, as I always say. So that's it for today, guys, and do like, share and subscribe if you liked this video and found it interesting, and thanks for watching.